Okay, in this session, we are going to have a mini project. And since this is right after the device simulator, we are going to use this simulator somehow. So as the motivation, again, so we are trying to kind of use oneM2M APIs for simple applications and simple projects. And in this session, we are going to have a practice on group fan out. And with the group fan out, of course, we can get multiple device or sensors measurements, or we can send out a multiple device control or actuations to through the group fan out. And actually, in this session, we have two different kind of projects. In the second one, we're going to have a really simple home automation service implementation with the oneM2M subscription, and this is the setup. And for this session's practices, you should download the source code from the GitHub link on the screen. So the main project one, we are going to use the device simulator from the last session, and with the other APIs interworking or kind of reuse for this device simulator. Um, there will be the better understanding of oneM2M APIs with group feature. As a scenario, we're going to create multiple device simulators. And in the project one, we're going to use the resource monitor to see what happens over the group fan out and the device simulator. So in this scenario, we're going to create multiple actuators using the device simulator. And of course, we will see what's the latest status or actuation messages on each device. And then we're going to send the control messages over the group fan out to those kind of actuators. And of course, we will see what happens or what happened to those devices with the resource monitor. So this is the resource tree design that we are going to try right now. And there will be the kind of lamp 1 to 3, and in each lamp there are kind of sub-container resources representing data and the command. Data is the sensor measurement, and the command is the actuation commands. And in the data, there are kind of sensor readings from the lamp and status reading. And for the commands, we are going to send the actuation messages into those command containers. And since we're going to practice on group fan out, there will be the group resource, which is gr lamp on top. And that group resource have members as lamp 1 to 3. And coming back to the device simulator, we will create the 5 different lamps, 1, 2, 3, 4, 5, and we're going to retrieve the current status, and then we will send a actuation messages to those light bulbs. And to do that, again, as we saw from the research tree, we will create the group lamp once we kind of create those lamps by the simulator UI. And to send the messages to different lamps at once, we will create the group having members, and those members would be the actuation container resources. And as you see from the screen, those members are like Mobius, lamp1, and command. So this is the container resource that we are going to send, or we are going to send the content instance creation as individual commands. So new commands will be created under this container resource. And when you send the group creation request, then we will get the response back like this. We create the group resource having those 5 members as we requested. Let's see how it works. Run the device simulator and create lamps for devices. So it can be the lamps or the other kind of sensor and measure actuator devices. So we have created kind of 5 different ones, and as the initial value given by the simulator, some ones are kind of light on and the others are light off. So this is the preparation for the research browser to see if we successfully send the command message over the group panel. So this is the group resource that we are now creating, doing 5 different columns, and of course those members will point out the individual command containers. Now it's time for us to kind of send the kind of group actuation messages over the fan out point of the group resource that we have created. And as you can see from the URL, we have created the Cathy. So let's check the current status of each devices over the group fan out retriever. So we have sent the request to the group resources for the child resource, which is fan out point FOPT of the group that we have just created. And when you see the response body, so there are responses aggregated here. Responses have multiple response from individual group member resources. For example, the first one is the lamp1 command, and we have kind of retrieve the kind of command, and the other kind of command resource for the lamp2, and the other. Now let's create the content instance child resource under those command containers. And as you can see from the left hand side, 3 lamps are kind of turned off, saying it is 0 at the moment. And let's send 1 to those devices. So all the uh, lamps will be kind of turned on because we have kind of defined 1 is turned on and 0 is turned off. So let's send it. So as the responses, so we have got the response saying that we have created a content instance under those command containers, lamp1 and lamp2 and lamp3. And when you send 0, as you can see from the left hand side, everything has kind of turned off, saying it is 0 at the moment. Of course, you can check it with the resource browser, but with the device simulator, we can see the current status with the GUI, so we saw it. Yeah, we already covered this part, so we have sent the control messages to different actuators, and we have seen those devices status have updated at once into zeros and into ones. And with the practice that we had just before, you can have a similar stuff in your application, your source code. And that's number one. And the other thing is creating the content instance over the group. So you can do the same thing because everything is just oneM2M APIs, and we have done it with the Postman, and now it's time for us to do the same thing with your source code. Again, firstly, you should create a group resource, and then you should be able to send the group fan out retriever and resource creation over the fan out of that group resource. So let's do it with the source code that we have provided over the GitHub repository. So this is the project, and let's see how it looks like. So in this one, we will create a group resource, and then we will send the content instance creation over the group fan out. In this function, there will be the content instance resource representation. So we are going to create this resource. Of course, the value will be given, and we call it. And we also create the group resource having this kind of representation. So this is just oneM2M standard compatible representation. And to create the group, of course, there are kind of lamp command containers, and just simply we chose two lamp one and two lamps. And to create the group, you should pick another name, and we created over the Postman. So this is the name that we chose, and we will run it. And there's a 3 seconds interval to create the content instances. Let's see the simulator together. So now it has been changed 1 and 0 because we created the group having just two lamps, 1 and 2. So when you kind of utilize this source code, then you can have your application with the oneM2M group, which is implemented in the source code. That's the project one, mini project one. And let's go to the second mini project. So as an overview, as we said before in the introduction, we are going to have a really simple home IoT automation service implementation. Basically, when the sensor reading goes up, we do something. When sensor reading goes down below the threshold, then we will do the other thing. So that's the home automation. For example, the temperature or humidity, depending on the sensor measuring value, we turn on something. And to do that, of course, we can retrieve the sensor measurement like every second, but since oneM2M provides subscription notification feature, we are going to use that one in this main project. And let's see how it works. So in this setup, we have the notification handling application, which is basically, again, oneM2M application. And there are sensors like the temperature sensor and the luminosity sensor or the other sensors that we can add in the device simulator. And when something happens as an event, we will catch it and we are going to actuate the other devices like the lamp, turn on and off, or we can kind of use the buzzer. So this is the scenario. So when the kind of luminosity sensor reading kind of becomes lower, then we will turn off the lamp because it gets dark. And when the sensor reading goes up over the threshold, then we will turn off the. This is the really simple home automation scenario that we're going to see really soon. And the device simulator, as we kind of practiced in the last session, it will automatically create the random value and by the interval. And as the new luminous sensor reading is created or stored into the oneM2M platform, we will get the new value over the notification and the notification handling application see the value, and depending on the threshold, it will turn on and off the lamp. That's the overall scenario. So let's design the research tree because in all the cases when we build oneM2M applications, including the home automation service application, we should design the research tree first. And in the CSC route, we create two virtual devices. One is the luminosity sensor, and the other one is the lamp as an actuator. And as we defined as the simple scenario, when luminosity sensor reading value becomes kind of higher than, for example, 300, then there will be the notification fire out, and each notification will be consumed by the home automation application, and it will send the actuation messages to lamp slash command as a actuation endpoint. So luminosity sensor has the data container, and we will create a subscription into that data container, and and the lamp will have the command container because that's the kind of endpoint that we will send all the messages as the home automation. So we will also practice on the research discovery that we kind of studied before. And the first thing is we will find the luminosity sensor, and this is the assumption that there will be maybe many uh, resources or the sensors that we have created, and to see what is the interested one, then we can fire out the discovery request to the oneM2M platform. And the next step is the uh, each container, sub-containers kind of resource ID. For example, we will send the command to the lamp like this. So we can kind of note that one, and we will send the subscription creation to the luminosity data, and we will send the actuation to the lamps kind of command container. So let's do this with the post. So now we have created the luminosity sensor named Lumi, and this is the discovery research. So we will send the subscription create request to that data, because when new content instances, which is the new sensor measurement, like 347 to 31, like that on the left hand side, we will get the notification when we create the subscription to that container. And we are creating a lamp, and when you see the kind of sub container resources of that lamp, there is the data and the comment. And we will send the actuation messages to that comment, which is the container resource. And we are going to look into the notification application, which is basically the oneM2M notification handler plus home automation application. And in the Noti application.js, you can configure your kind of environment like the IP and the port. So this is the Noti application.js, and there is the IP and the port. Then you can change depending on your environment. And there is the subscription creation. And when you see that, we use HTTP, for example, and we will get the notification in JSON. So this is the syntax that oneM2M defines. And this is kind of important in this practice. So NET means notification event type, and there is a array of enumeration. And 3 means child resource creation. And as we saw before, we will get the new sensor measurement, and the new measurements are the content instance as a new resource creation under this data resource, and we are creating a subscription to that data. And to get this new content instance creation, the notification event type shall be child resource creation. So whenever there's a new creation of the child, then subscription will catch the event and send us the notification. And of course, we don't use it at the moment, but there's other event types. For example, when the subscription target gets updated, then you can get the notification, and the notification will contain the resource representation, which is updated in the notification. So that's the concept, and we will get the new content instance representation by this setting. And there's the notification handling procedure over here. And one npm notification is sent over HTTP post, so we will get the post, and we are parsing the data, and depending on the threshold is 300 at this moment. Depending on it, if that is bigger than 300, then light off. If that is kind of smaller than the kind of threshold, then we will turn the light on. So let's run it. So now from the console, we are looking at the notifications that is coming in from the Mobius, and the value is still over 300, so the light is off as 0. And let's wait for the other value on the 300, 348. Still waiting for it. Yeah, 260. So we have turned the light on, and now the light is off again. So this is the really simple home automation, having one sensor and one actuator. And we already covered over the uh, code. If you're interested in the other kind of event types, you can change or you can even add, because this is the array and notification handling function, parsing the notification object, and as we kind of studied before, uh, notification, the root key is m2m colon sing sgn, which represents single notification, and inside that there's a notification uh, data, and it has the representation, and the representation contains the content instance resource object, and it starts with the m2m colon cin. Yeah, this is the installation and the running of the Noti application, but we somehow kind of skip it over. So just for your information, when you kind of download it, you should install all the dependent modules with npm install, and then run it with the Node notification. And we saw the notification messages that is kind of coming from the Mobius from the console. So each notification looks like this, and then SGN single notification, and there's the other kind of key values like subscription reference. What is the subscription that is generating the notification? In this case, before we created the subscription under Mobius Lumi data, and this is a subscription resource name that we have created, and we get the value and we parse out the value, and since this is over 300 we do nothing, and when it becomes lower than 300, then the room is dark, for example, so we switch the name status into 1 to turn it on. So after this kind of simple automation service practice, you can kind of extend into different scenarios. For example, you can create a presence detection sensor and the buzzer. When there is a kind of presence kind of sensor measuring, if someone is entering the room, then the buzzer will be kind of turned on, for example. And if you do some more kind of coding, then you can have the other scenario, for example, in 5 seconds, for example, if the sensor is kind of detected, then the buzzer will be kind of turned on. And for example, in 5 seconds or 10 seconds, if the sensor measurement is kind of bigger, bigger than 3, I mean, the notification messages are received over 3 times in 5 seconds or 10 seconds, then there's no error, and definitely there is a unexpected person coming into the office or the room, then there will be the security buzzer turned on. So those are the all the scenarios that you can think of, and you can extend the sample application that we provide. Thank you.